let's have a look at question 2. So this is a force of motion question. Let's have a look. A rough plane is inclined to the horizontal at an angle alpha, where tan alpha equal to 3/4. So straight away we can draw a right angle triangle. So this is alpha, opposite is 3, adjacent is 4, so hypotenuse is 5. Then we will know sine alpha is 3/5, and then cos alpha equal to 4/5. We're gonna need it later. And then a small block B of mass 5 kg is held in equilibrium. So that means 5g weight goes down, and that will be a normal reaction R. And then resolve this, one perpendicular to the plane, one horizontal to the plane. So if this one is alpha, this would be 5g cos alpha, because that's adjacent. And this one is opposite, so that'd be 5g sine alpha. And then so it's holding equilibrium on the plane by a horizontal force of magnitude x newtons. So again, we need to resolve it to one perpendicular to the plane, one parallel to the plane. And then if this one is alpha, so this would be x sine alpha, and then this one would be x cos alpha. So one thing you need to be careful. So because vector is magnitude and direction. So since this force is a vector, so if the arrow goes like this, it's from this point to that point. So that's why when we resolve them, so it has to be goes down and then goes to this way. So it has to be drawn like this. Yeah. So it's not gonna be something like this, because if you draw like this, then it's from this point go to that point. But what we want is, this is our starting point. And then this point is our end point. That's why it has to be goes down first and then go to the right-hand side or up. Yeah. So you need to be careful on that. And then also the reason this one is alpha is kind of obvious, but if you're not sure, you can see those two lines are parallel lines. That's why those two angles would be alternate angle. Let me use a different color. Yeah, this is alternate angle. That's why those two has to be the same. All right, and now we get all the forces labeled, and then they have the magnitude of the normal reaction is 68.6. So then this force has to be 68.6 Newton. And then because it's a rough plane, that would be a friction. So friction is always opposite to the moving direction. But in this case, they didn't say like it's gonna move up or gonna move down. We don't know. We can just label the friction any direction you want. So if eventually you work it out to be positive, that means the same direction as you choose at the beginning. If eventually you get negative, that means the friction should be opposite to the direction you picked at the beginning. Yeah. So in this case, I will just assume it's gonna move up, like the party, because of the force X. I just assume the particle is about to goes up, then the friction just goes down. So let me just label like this. Yeah. So if at the end the friction is positive, then it should be goes down. If the friction is negative, then it should be opposite as what I did. So it should be goes up. Yeah. So to set this one up, because it's an equilibrium, that means in the direction which is perpendicular to the plane, so up equal to down. So up is just 68.6, and then down should be x sine alpha and also 5g cos alpha. So you can see this force in the perpendicular direction but goes up, and then this force in the perpendicular direction which goes down, and so does this one. So it's only these three forces. Yeah. And then you can see there's only one unknown, which is just x, because we know what sine alpha and cos alpha is. So we can put in straight away. So we have 68.6 is equal to x times by sine alpha 3/5, and then plus 5g times by cos alpha, which is 4/5. Then rearrange them, 68.6 minus 4/5 times by 5g equal to 3/5x. So then we can just put this in the calculator, 68.6 minus 4/5 times by 5g, and that will be 29.4 equal to 3/5x. So x is just equal to 29.4 divided by 3/5 for both sides. So if we divide it, it's just 49 newtons. So now we work out the x value. If we look at the direction which is parallel to the plane, then the forces which is parallel to the plane is just this one parallel to the plane, and then friction parallel to the plane, and also this one, which is 5g sine alpha, is parallel to the plane. So to set them up, so parallel to the plane, we have x cos alpha upwards, and then friction and also 5g sine alpha go downwards. And then we know what cos alpha is, which is 4/5. And then we know what x is, which is 49. And then friction is what we want to find out. And then sine alpha is 3/5. So friction should just be 4/5 times by 49. And you just have to minus 5 times 9.8 times by 3/5. So we have the friction to be 9.8 newtons, and it's positive. So that means the direction we picked at the beginning is the correct direction. So you just have to say 9.8 Newton down the plane. Then that would be the answer for part A. And then for part B, the horizontal force of magnitude x Newton is now removed and B moves down the plane. So we need to draw a new diagram. So particle B is still here, and then it still has weight 5g, and there'll still be some normal reaction. But because the forces are different now, so the normal reaction is not 68.6 anymore. We don't know what that is. Yeah. And then this is still alpha, and then this one will still be alpha. So if we resolve them, still 5g cos alpha, and this is 5g sine alpha. And then they tell us this time B moves down the plane. So if B moves down the plane, the friction has to be opposite to it, because the friction is always opposite to the moving direction. So this time friction will go downwards. So they tell us the coefficient of friction is 0.5. So because it's moving, that means it has to be maximum friction. So you can just write as friction is equal to mu, which is 0.5 times by r. That's everything we have. Yeah. So now we can set up the equation. So the one perpendicular to the plane, up equal to down. So r equal to 5g cos alpha. And then we know cos alpha equal to 4/5. To simplify that, that's just 4g. And then the one which is parallel to the plane, because it's moving, so just F equal ma. So force goes down, 5g sine alpha, and then force goes up, 0.5 r, and that's equal to mass, which is 5 times by acceleration. That's what we want to work it out. So 5g times by sine alpha 3/5 minus 0.5 times by r, which is 4g, is equal to 5a. So simplify that, this would be 3g. And 0.5 times 4g, that's just 2g, but 0.5 times 4 is 2, equal to 5a. So then g equal to 5a divided by 5 is just 1/5g meter per second square.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.